Hello, thank you for joining me. Today I will present my final project for the Harvard CS50 Introduction to SQL course. My project named MyTechStore is a custom database designed to help users manage a small shop specializing in selling and repairing electronic devices. This database is mainly composed of 12 main tables, 4 junction tables, 6 indexes, 11 views, 14 triggers, and 24 stored procedures. To better understand the database, I present to you the full entity relationship diagram of my database. It may seem complex at first glance because I tried to model a real-world repair and sell business. I won't go in full detail here, but in the next slides, I will highlight some key components that power the database and explain the main reason behind their design. Now let's take a closer look at some of the key components of the database. We will focus on 3 of the most important tables, followed by a view, a stored procedure, and a trigger to highlight how they work together to support core operations. We will start with the products table. This table stores all the essential details about each product in our system, such as its type, brand, model, price, stock quantity, and warranty period. It uses a check constraint to prevent negative stock values. It also uses the unsigned constraints for numeric values. This slightly reduces memory usage and helps reducing the overall database size. This table also uses a soft deletion mechanism through a deleted column, allowing us to mark records as inactive instead of removing them permanently from the database, which helps maintain historical data. Next, we have the sales table, which tracks customer transactions. It links each sale to a specific customer and product and stores the quantity, total amount, and sale date of that transaction. Just like the products table, we use the unsigned constraint in fields that only requires positive values to reduce memory usage, and we also implemented the soft deletion mechanism to preserve historical data. The repair requests table manages all repair-related activities. Each request is tied to a customer, a technician, and the product needing service. To enforce consistent tracking, the status column is defined as an enum, limiting it to just 3 valid values: pending, in progress, and completed. This helps prevent data inconsistencies when updating repair request statuses. Like the other core tables, it uses unsigned constraint where appropriate and also supports soft deletion. Since this database contains many views, stored procedures, and triggers, it would be difficult to cover them all in a short video. Instead, I'll walk you through a few examples that demonstrate the reasoning behind these components and how they support the database's overall functionality. Here's an example of a view named Open Repair Request. This view provides a list of repair requests with a status of either pending or in progress. It joins data from 3 tables: repair requests, customers, and products, allowing us to generate a more detailed and useful report on active repair cases. As shown on the right, each row provides key information, such as the repair ID, customer name, product involved, issue title, request date, and the current status. This view helps managers quickly track ongoing repairs and allocate resources more effectively. The next example is a stored procedure named Calculate Repair Costs. This procedure was created to automate the calculation of repair costs based on the spare parts used. It accepts the ID of a repair request as an input and returns the final estimated costs. Stored procedures like this help ensure consistency in calculations across the database, while also reducing repetitive logic in applications that interact with it. Finally, here's an example of a trigger named Update Products Stock After Sale. This trigger is automatically activated after a sale is recorded, and it decreases the stock of the corresponding product. It helps keep our inventory accurate in real time, eliminating the need for manual stock updates and reducing the risk of errors. That concludes my presentation. Thank you for watching. Goodbye.